Hi, this is lesson 7.3, use functions involving e. So e is just a number. It's a letter that stands for a number. It's called Euler's number. The big question here is, when is the natural base e useful? So when will we use this? You should learn how to use it, how to graph it, and when we actually use it by the time you're done with this frame. So here's your frame. Let's look in your notes. The functions involving e's frame is about the different ways we can simplify and use e. That's what this whole frame is about. So let's look at our first column, some basic information. Euler's number is this right here, 2.71828.128. But then you need to remember that it keeps going on, so we'll put a few dots after that. And the way this is found, if you do 1 plus 1 divided by a number and raise it to that power, as n approaches infinity, so as n gets bigger and bigger and bigger, when you simplify it, you get closer and closer and closer to Euler's number. So that's where e, or the natural base, is found. So let's evaluate these. All you really need to do is put them in your calculator. You have a button in your calculator that has e right on it, so it should be pretty easy to use. It probably looks something like this. Okay, probably looks like that. So pause the video and put these in your calculator and see if you get this. Okay, welcome back. You should have these filled in, and you should get, for this one, about 1.433329.415, and it keeps going. For this one, you should get approximately 0.0183156.389, and again, that would keep going. And for this one, you should get approximately 10.5850008. If you didn't get those, pause the video, try and mess with your calculator a little bit more to try and get those numbers. If you still can't get those exact values there, make sure you ask in class tomorrow how you're supposed to do this on your calculator. The next part of the frame is just simplifying with e. So to simplify in example 1, remember when you're multiplying, you add your exponents. So this would become e to the 9 plus 5. Or actually 9 plus 6, I read that wrong, 9 plus 6, which equals e to the 15th power. So when you're multiplying like this, you've got multiplying and you've got the same base, you're going to just add your two exponents. Let's look at this next example problem. So notice how this 2 is on the outside of the parentheses, so we need to give it to both of these two pieces inside of the parentheses. So this equals 4 squared times e to the third. It's kind of hard to write really little with this pen that I'm using. E to the third squared. That's a 3 right there. Over, let's just keep this 8 e to the 5th. 4 squared is 16. E to the third squared, when they are right next to each other like that, you just multiply them. That's e to the 6th. So we have 8 and e to the 5th still on the bottom. And then if we just simplify up and down, 16 divided by 8 is 2. And here we're going to subtract our exponents. 6 minus 5 is 1. So our answer is 2 e to the first, which we don't really need to write that first power, we just write 2e. Here on this next one, we're going to give this 3 to this piece and this piece. So we're going to give it to both the pieces on the inside of the parentheses. So that's negative 10 to the third power, and also e to the negative 5x to the third power. Let's simplify this a little bit. This is negative 1,000. E to the negative 5 times 3 is negative 15x. So you could keep it like that. Or, remember, since this has a negative exponent right here, really what you want to do is get rid of that negative exponent. So because we want to get rid of it, this e to the negative 15th power is really on top of the fraction now, so we could just move it to the bottom of the fraction. So, or, you could write negative 1,000 over e to the positive 15x. And that's technically a little bit more simplified. Let's simplify this example 3 here. Notice we've got a fraction under a radical sign. We definitely don't want to have that. So we're just going to multiply here. And if you think about it, 4 times 27 times e to the 13th times x, well, that parenthesis doesn't really need to be there at all. So we can just do 4 times 27, and 4 times 27 is 108. I still have e to the 13th power. I still have x here. I've got 3 on the bottom. I've got e to the 7th on the bottom, and x to the negative 3rd. Well, that x to the negative 3rd, we don't really want a negative exponent, so I'm going to move it to the top and make it x to the positive 3rd. We've still got our radical sign here, so let's keep it. Now let's do a little bit more simplifying here. 108 divided by 3, well, that right there is 36. So now we've got 36. E to the 13th over e to the 7th, we just subtract. 13 minus 7 is 6. So this is e to the 6th. X times x to the 3rd is x to the 4th. We've still got our radical sign here, so we need to simplify a little bit more. So we're going to make this the square root of 36 times the square root of e to the 6th times the square root of x to the 4th. Simplifying that, square root of 36 is just 6. The square root of e to the 6th, well, this is really the second power, or I'm sorry, the 1/2 power. So e to the 6th to the 1/2 power is just e to the 3rd power. When you have a radical with a power inside of it, you can just divide that power by 2 when it's an even number to simplify it. And then we'd have x to the 4 divided by 2 would be 2, since that's an even number. So our answer, our final answer here is 6 e to the 3rd times x squared. Well, let's look at a real life example here. Compounded continuously, this is something that you see often in finances. And we've got this general formula, A equals P times E to the RT. And this is a great way that we use E. This is when we compound interest continually. So P is our principal. It's the amount of money that we put into an account. R is your rate. And we got to make sure we have that as a decimal. So our rate as a decimal. And then T is our time. So let's look at this first one. It says you deposit $3,500. So right there, $3,500 is our principal in an account paying 4% interest. So 4%, if we put that as a decimal, it's 0.04, compounded continuously. That's our key that we're using this formula. What is the balance after 2 years? So let's write out our equation. A equals P, our principal, we said was 3,500, times E to the R as a decimal, our rate is 0.04, times T, our time, is 2. And if you just put that into your calculator and simplify it, you get about $3,791.50. Let's try this next one. What you could do is pause the video and try it on your own. That would be great practice. Okay, so we use our formula here. A equals, says you deposit $4,800 in an account. So 4,800 is our principal. It says it's paying 6.5% interest compounded continuously. So we know this formula works here. So we're going to do e to the 6.5% is 0.065 as a decimal times, now we just need our amount of time, and it says what is the balance after 3 years. So we're going to multiply that by 3. If you put this into your calculator, you're going to get approximately $5,833.49. Let's look at this last problem. It says in biology, the length L in centimeters of a tiger shark can be modeled by L equals 333 minus 276 e raised to the negative 0.178 t. So we've just got a formula here. It says what is the length of a shark at 4 years old? So our t is 4 here. So let's just plug 4 in. 337 minus 276 e to the negative 0.178 times our t is 4 for 4 years. And if you put that into your calculator, you're going to get approximately 201.58, and that's centimeters, and it's that many centimeters long. Okay, why don't you flip your frame over now? We're going to do the other side. Functions involving e still. This side is about graphing natural base exponential functions of the form y equals a times e to the rt power. So our main idea here, and you're going to need to fill this main idea in, you got to remember if a is greater than 0 and r is greater than 0, then the function's exponential growth. If a is greater than 0 and r is less than 0 though, so if your rate is less than 0, that's when your function is going to be exponential decay. So let's try these graphs. Our first graph, we're going to graph just y equals e to the xt power, or I'm sorry, e to the x power. Remember, our general form for all of these is y equals a times b to the x. So if I put a number in here, I could put a 1 right in there. So my y-intercept is still going to be 0, 1. We're going to use a lot of the ideas that we used previously in 7.1 and 7.2. My domain is still going to be all real numbers. My range is still going to be all real numbers greater than 0. And my asymptote is still going to be the line y equals 0. So let's draw that asymptote right in there. We can't forget to do that. Our transformation, well, since a is just 1, there is none. So let's make a table of values to graph this. I'm going to use xy. I'm going to use negative 2 again, negative 1, 0, 1, and 2. So this, I'm just going to put into my calculator, and I've already done that. That's where I'm coming up with these values. If you want to pause it and make sure you can get these values on your own, go ahead and do that. Here you should get 0.14. I'm just going to give 2 decimal places. For negative 1, you should get 0.37, or 37 hundredths. For 0, you get 1. For 1, you get 2 and 72 hundredths. And for 2, you get 7 and 39 hundredths. So let's graph these. I'm going to graph negative 2, 14 hundredths. That's really close down here. Negative 1, 37 hundredths would be a little bit further up. 0, 1's already on the graph. 1, 2, and 72 hundredths is right around up here. And then 2, 7, and 39 hundredths would definitely be off my graph. So let's just connect these points to form our graph. Remember, it should go close to the x-axis, but it should never touch it, and it should never ever cross it. So there's my graph, and you should be getting used to graphing these by now because we have graphed many of them at this point. Our next one, y equals e raised to the opposite of x power. So just like before, y equals a b to the x. There's our general form for these problems. So I could put a 1 right in there. So my a value is 1. So I've got 0, 1. And if you think way back up there at the main idea, if I've got a negative exponent here, then this is going to be decay. So my previous problem I did was growth. This one is going to be decay. So my domain or my y-intercept is 0, 1. Let's put it right here. Knowing that it's decay, you should expect your graph to fall or go down from the left to the right. My domain is still all real numbers. My range is still all real numbers greater than 0. My asymptote is still the line y equals 0, and let's draw that right in so that we don't forget about it. So there's my asymptote. Transformation, again, my y-intercept didn't move at all, so there is none that we need to worry about. So let's just make our table here. So again, -2, -1, 0, 1, and 2. And you'll just want to plug these into your calculator to simplify, but you'll find these numbers are just the reverse from the example we previously did. So -2 is 14 hundredths. If you plug -1 in, you get, I'm sorry, I said that one backwards there. -2 isn't 14 hundredths, I was looking at the wrong one, it's 7 39 hundredths. -1 is 2 72 hundredths. 0 is 1. If you plug 1 in, you get 37 hundredths. And if you plug 2 in, you get 14 hundredths. So again, these are just reversed from the example we did prior to this. So let's put these points on our graph now. -2, 7 39 hundredths will be off the graph. -1, 2 72 hundredths will be right up here. 0, 1's already on our graph. 1, 37 hundredths will be right down here. 2, 14 hundredths will be really close down here. And then we'll connect these with a nice exponential decay curve. And my graph looks just like that. Let's try the next problem here. Okay, in this example, we're going to graph y equals 2e raised to the 6/10 times x power. Now, remember, we got y, and I keep moving this around for some reason. We have y equals a times b to the x power, and in the a position here is 2. So we know our y-intercept is going to be the point 0, 2. And we also know that we've got a transformation going on here. So 0, 2 is right here on my graph. Okay. My domain is still going to be all real numbers. My range, since I didn't reflect this across the x-axis, is still going to be all real numbers greater than 0. And my asymptote is still going to be the line y equals 0. So let's draw our asymptote in right now. So there's my asymptote. A transformation, we know since a is 2, that we've got a stretch of 2. Let's now make our table of values. So I've got -2, -1, 0, 1, and 2 for my x values. And if you plug -2 into the equation and simplify, you'll get 6/10. It rounds to 6/10, even giving 2 decimal places. Giving 2 decimal places again, if you plug -1 in, it rounds to 1 and 1/10. 0, we know, gives us 2 because that's our y-intercept. If you plug 1 in, you get 3 and 64 hundredths. And if you plug 2 in, you get 6 and 64 hundredths, and that would be off our graph, so we won't worry about graphing that one. So -2, 6/10 would be right around here. -1, 1 and 1/10 is going to be right around here. We've got 0, 2 on the graph already. 1, 3 and 64 hundredths would be right around, actually right up here. And then let's draw our nice curve in. So there's my graph. And this is definitely a growth function just by looking at it. And that might be one thing that you could kind of quiz yourself, look at all the graphs and pick out whether they're growth or decay. This is definitely a growth function though. And that's all for this example problem. Now this problem is a little bit different because we've got a translation going on here. So you've got to remember this -1, that's going to tell our graph to go right 1. And this -2 back here is going to tell us that we need to move our graph down 2. So we're going to go right 1 and down 2. But we need to first graph and make a table of the equation y equals e times negative 0.35 times x. We first need to use this right here. So let's make our table. I'm going to make it right up here. That's -2, -1, 0, 1, and 2. So if I plug -2 in, I get 2.01. If I plug -1 in, I get 1.42. If I plug 0 in, I get 1, which we can tell because that would be our a for this function. If you plug 1 in, you get 70 hundredths. And if you plug 2 in, you get 50 hundredths. So let's put these points right on our graph. -2, 2 and 100th, or 100th, that's right. It'll be right here. -1, 1 and 42 hundredths would be right around here. 0, 1 is right here. 1 and 70 hundredths would be right about here. And then 2 and 50 hundredths would be right about there. So here's my graph. I'm just going to do it in a different color because I need to move these points. So I want to be able to make sure I can see my points really well. So here's my curve, and that's decay. You can see by that just by looking at it, that's going to be exponential decay. Now let's move all these points right 1 and down 1. So if I start here, start right here and go right 1 and down 1, I'd end up right here. I'm sorry, right 1 and down 2 would actually put me right here. If I take my next point and go right 1 and down 2, it'd put me right about here. This next point is my y-intercept. So I'm going to change my y-intercept because now it's not a y-intercept. We're going to call it our starting point. And we want to be really careful and see where it moves to. I'm trying to write starting point up here. So this is our starting point. And our starting point goes right 1 and down 2, so it moves over here to 1, -1. So 1, -1 is right there. I'm going to fill that in as my starting point. Let's move these other 2 points. If I go over 1 and down 2, put me right about here. And then if I move my last point, right 1 and down 2, put me right about there. So let me draw my curve in. Okay, let's fill in our other key information that we need to know. Our domain is still all real numbers. Our range is still going to be all real numbers, but let's look and see what happened to our asymptote. Our asymptote was right here, but if I move it down 2, my asymptote ends up being this line right there. So I'm going to draw that asymptote in there because I'm going to use that to help me with my range. So my range is going to be all real numbers greater than -2. My asymptote is the line y equals -2. For transformations, there was no stretch here, and we know that because my a up here is just 1. So I know there is no stretch. So all I have to put for my transformation is right 1 and down 2. And remember, I had said we should definitely highlight. We definitely should highlight what our final answer was. So I'm going to take a second here and highlight what my final one was. And whoop, that's a little bit too dark, so let me change that. There, that looks better. So this was my final answer right here for the graph. So I just highlighted it to make sure I know exactly which one I want. And that is the end of these notes. Please make sure if you have any questions on any, or there were some that you didn't understand, you star them so that we can go through them in class tomorrow. Have a great day.